Welcome, ladies and gentlemen. If I get a nice big round of applause for our next presenter, Simon Finch.
Okay, thanks for coming. Okay, I'm the NOC Monitoring Event Manager for Westpac in Australia. I doubt that many of you have actually heard of us. We're a little bank down under. We're actually Australia's oldest bank and the first one. We've got our bicentenary coming up in a couple of years' time. We're the world's 9th largest bank. Got some good awards this year. Most sustainable bank, thanks to you guys and the Dow Jones. We're also supposed to be named as the world's most ethical companies. We've got 12 million customers, 57,000 shareholders, 37,000 employees, and 1,300 Australian points of representation. That's a mixture of branches, agencies, and we've got offices in all the capitals, all the financial capitals around the world. So we're a fair-sized operation. This presentation will hopefully give you a bit of an overview of the size of the monitoring landscape and then some of the things that we've done along the way, that we've actually learned along the way. The way we did some of our dashboards in the early days were not very good. We're getting a lot better at it these days. Also, we've done service integration. I've done it twice into 2 different service desks from 2 different monitoring systems, and currently we're doing it with Nagios and Remedy. And also, one of the more stranger things that we do is we've actually integrated alerts from our mainframes, and I'll go into why we had to do that. It sounds scary. It's actually very easy to do. So the monitoring landscape. Okay, don't know why that happened. Okay, Westpac's multi-branded. Westpac is a large bank, but it's actually taken over many other smaller banks along the way, which is why it's quite large. So we've got a mixture of insourced and outsourced IT, and I'm working on the insourced side of it. The outsourced is through a major vendor that all of you guys know, Big Blue. Nagios is used extensively throughout the insourced IT brands. And SGB, St George, Bank of South Australia, Bank of Melbourne, they're all subsidiaries of Westpac, and we monitor all of those with Nagios. So back in 1998, we actually started monitoring our environment with one of the large vendor frameworks from a very well-known company. I was part of the original team that deployed that. I was a team member at the time. Then in 2004, I started to have a lot of gaps, noticing lots of gaps that I couldn't fill with the vendor's product. Now, the lack of monitoring of simple things like DNS, NTP, DHCP, and all the network-bound services that typically Nagios actually does natively, these were quite difficult to do with the vendor solution, and their solution to fixing the gaps, was to actually use more of their product and pay more, quite extensively more. So I decided to give Nagios a go instead and started using Nagios to actually fill the gaps. Now, I was doing this for about 2 years, and I started to notice that I was using more and more Nagios and less of the other stuff. And I started to really question why we were paying so much in licensing fees, like in the millions, to a vendor when Nagios was replacing their stuff and doing a better job. So 2006, I went out on a limb and I decided that's it, and I started deploying Nagios across our enterprise. And what actually happened was 2 things, or 3 things. The bigger 2 was that we had a complete shift in the way we did monitoring. With the vendor solution, it was very difficult to monitor things. So what happened is that we had a monitoring team, and it was very much like an ivory tower where the monitoring team, if you wanted to get anything monitored, the monitoring team had to do it, which caused a backlog. And I was the team leader at that stage. And we had a huge backlog of work, and we had the us and them problems where The system administration guys were wary of these monitoring guys coming in and doing stuff to their systems and doing monitoring to them. So what happened when we went with Nagios is that it became so easy to monitor stuff that we pushed out the monitoring down to our system admins, and they embraced it because they owned it. So we went from a complete shift with the us and them to everybody's best buddies, and we got a lot more monitoring done. What actually happened as a result of that, in 6 months of monitoring with Nagios, we got deeper penetration into our customer applications than we got with 8 years of the previous monitoring. Because with the previous monitoring, we were banging our heads against walls all the time. With Nagios and the system admins doing their own and also the support teams doing their own monitoring, all sorts of doors opened, and we got much better quality monitoring. Primarily because the system admin guys and the application support guys, they know their systems far better than us monitoring guys will ever know it. We know how to monitor stuff, but they know what goes wrong. So they knew where to deploy the monitoring. We just give them a hand help with actually making it work, and they had the ideas. And the best part too is that as we grew with our monitoring, we didn't need any more bodies to actually look after the monitoring, because the system admins and the support admins were doing their own work. All that we've provided the monitoring system, and they did their own work. The other benefit of that was that we ended up with all of their data coming back into a central repository, so that we're able to do then enterprise-wide dashboards for NOCs and support teams. The other thing that we actually got as a result of that was agents as part of server builds. Because now all of a sudden we had system admins who really wanted our monitoring, and whereas before they were resisting us for putting agents on, and in fact we had quite severe problems with agents being sabotaged, now all of a sudden it turned around and we had these guys building in our agents into Unix, Linux and Windows systems as they went out. So it became much easier and we got things done much quicker. Monitoring today. The two panels there were actually screenshots from our monitoring system back in September. So we're just short of 4,000 hosts. We've got 37,000 services, all being actively monitored. We don't do any passive monitoring, everything's active. All of our critical applications are all monitored. And we're not just talking about ping and servers, we actually go right deep into them, making sure services are running, making sure they're actually processing transactions. A lot of the stuff we monitor is customer facing, so it's critical that it's up. We also monitor systems that are in our branches, that our tellers are standing behind a counter with the customers in front of them, and if their system's not running, customers get angry pretty quickly. So we'll start off with the dashboards. That's a standard NOC dashboard. Literally, it's being used right now, and that's one that was done, or that snapshot was taken in September. We've gone from little dots to bigger blobs. Simple things, but basically what we found is that you get more attention if they're brighter, short and sweet, bright and colourful. So what we get from that is we get all our applications that we care about. We've got thousands of apps, but these ones here are actually, they're not individual apps, they're actual business services. So what we see is our major services are status at a glance. We keep them bright and colourful and simple. We find that simple is effective, and I'll show you why in a minute. Every one of these traffic lights, you can drill down and get down to the actual topology of the application itself or the service, and find out all the components that are running under it. We timestamp them. Nasty problem that we had is that these are all done with NAGVIZ, and one of the problems that we struck was that being that it's browser-based, it's quite possible to have an interruption in the connection back to your web server, and when that happens, your dashboard effectively becomes static, and the operations guys don't notice. Everything looks green, they're happy. So what I've made sure we do is we timestamp all of our dashboards so that we know that, make sure that they're updating. And we just do that with a worker thread off of NAGVIZ. And yeah, it's all done with NAGVIZ. That's an early example of one of our dashboards. It's not particularly good. We started off by taking application diagrams, infrastructure diagrams, and then laying servers and services over the top. And we're all happy with that for a while, but what you started to notice pretty quick was that by just laying them straight on top of their diagram, you ended up with the top level being red quite often. So then we evolved into something like this, and it's not a lot better. It was getting there, but it's not better. It gets more information. I should point out too that that diagram there is actually a live diagram. It's still used today. It's one of the ones I'll be updating when I get back. The only difference between the one that you see here and the one that we see in the shop is I've had to remove the server names and the service names. So then we tried this one. That was getting better. That was more of a logical layout rather than an infrastructure layout. Same problem though, far too much detail on the dashboard. It's quite easy for people to miss what's going on if they're using this, and these are used by application support teams. So today what we do is more like this. So rather than showing dots on infrastructure diagrams, which is how we started, now we go to more of a brighter traffic light control. It draws attention, basically. It's much easier for people to notice. Just another example. That's actually our Nagios dashboard. We monitor ourselves. And every one of these boxes there actually represents a server within. So not only that, but we also infer information by the position on the diagram. So for instance, in this case, everything on the left-hand side is our major data center. So the DB master and all the Nagios servers on the left are in our master data and our primary data center. The DB slave, all the ones under it, and all the Nagios servers on the right are actually all in our slave or secondary data center. We had some interesting fun dashboarding VMware. One of the problems with VMware is you've got to monitor a lot of metrics to make sure things are going because there's a huge amount of redundancy. So we do monitor and trap all the metrics from each ESX host, but we don't show them on the dashboard. And we have to do a lot of monitoring, a lot of clustering of metrics. So we do that per cluster so that we're more interested if there's a cluster issue, an ESX cluster issue, as opposed to an ESX host issue, because of obviously the way things move around on VMware. The fact that things do move around on VMware with vMotion also adds some complexity. So we've avoided actually monitoring guests running on particular hosts, and instead what we do is we tend to use the cluster as the center of the VM world, and we tag hosts onto clusters, and separately we tag guests onto clusters, because we know that they're always going to be there. Because trying to chase guests around which server they're running on which particular day just became too much, and we really don't need to know. This is an application dashboard that is used by our hosted desktop guys. So we're running a lot of our desktops now on hosted sessions, and this one gives them the info that they need. The top level status actually shows there's nothing wrong because VMware clusters have so much redundancy, so that's actually all green. It shows nothing wrong. If you actually hover over each of the clusters, it'll tell you what's going on, give you more info if there is a problem, and then you can drill down deep into it. And these are all done just by linking maps to more maps within Nagios, so just using simple things like that. So you hover over it and it'll give you the status of the cluster. Drill down shows the support team information because at the high level, that original map, this one, that's actually shown on a monitor, not quite as big as the one behind me, but certainly as big as the ones in front of me here. So they're up on a large monitors in the application support team areas, so they've got at a glance, they know what's going on. When they do detect problems and they need to dig in deeper, Hover will give them a brief overview, but then we've got when you actually click on any particular cluster, it then gives you far more detailed information. So we can see from this that we actually, on a particular cluster here, we actually do have issues on some of the ESX servers, but they're not affecting the service to the customers, so we don't mark it on the top level. We still do notifications out to the support team via email and SMS if there's issues at this level, but we don't change the upper level NOC maps because the NOC don't need to be involved in managing incidents. Our application support teams, they have specific customer requirements. So because they use these things on large monitors in their support application areas where they work daily for day-to-day work. Everything that's on their map is then rolled up to the NOC map. So this is one that was done. We did this to the team's request. And again, this is a live map. The only thing that's changed is the server names across the top. So this one here gives them an idea of what's going on. Being a bank, we have to, I'm not sure about other companies, but I know in banking we have to keep a record of all the communications in the company for 7 years for APRA requirements. So this is the system that actually does that. And as you can see, we're starting to run out of space on our DB servers. So but the guys have got plenty of warning, so they know to provision more space on their servers. And then what happens is that because this is an important system, it actually rolls up, and down on the bottom row there, Archive Manager, it's yellow. That's the yellow on this one's actually causing that. This is just another brief example of application support team, a different one. This is imaging. We need documentation in a lot of companies these days. Large companies is not held in paper anymore. We used to have warehouses full of paper for storage, again, because we've got to save everything for 7 years. Everything's done with imaging now. So this one here is a live imaging system status of what's going on. Everything from scanning the documents in to storing them. We've been doing all of this stuff. Everything you've seen has all been done with Nagios. What I've found with Nagios is extremely flexible. Is there anybody here who does or doesn't use Nagios? Does everyone know what I'm talking about? Yeah. So what we also found this year is that you can actually enhance Nagios significantly by using live status. And I'll give you an example here where we actually enhanced a dashboard. It was required for a customer request, but we enhanced it using simple Perl code. And I'll actually show you the Perl code because it's literally only a handful of lines of code. And once you do this, you can actually enhance. We've only done one simple calculation and displayed it, but once you go this way, pretty much anything you can extract out of Nagios with Perl and live status can be then manipulated and displayed on a dashboard. This code here in the presentation is the actual code that I use. It's not particularly elegant, but it is simple. The only thing that's changed is the server backend hostname and port. I've just left those as hostname and port. Other than that, this is the code that's used. What this one does, this is an example of a map that we use to actually show branch status around the country. And what Nagios by itself couldn't do was give us the statistics in the little boxes. So we've got a couple of things going on there. The first digit on the left shows you the number of failures, the number of branches that are down in any state, and the one on the right shows you the total number in that state. And what we were asked to do was something very simple, and that if you've got 4 or less branches down, make it yellow. If you've got five or more branches down, then make that box red. Now the actual the numbers that are there, we couldn't get out of Nagios using Nagios, but we can get access to them through live status. So just by some very, very simple code and some basic mathematics, we were able to produce this sort of information, which is what made our branch managers very happy. So with dashboarding, what we found overall, we've been doing this for a few years, simple is effective. As you saw from the early examples, we went far too complicated on our early dashboards, and they really didn't work. With too much detail on there and not enough clustering of metrics, what you find is that your top-level NOC maps typically stay red all the time and become useless. What we're after is a clear status of our applications, okay? Is the thing really affected? If it's red and it's not broken, very quickly, NOC staff will ignore it. So it's very important to make sure that we're showing the truth on these things. And we're not quite there yet. We do get there on a lot of our apps, but we've still got a few that need retrofitting. Simple colour, broad colours, bold colours, just to keep everything bright. Again, in the early days, too small, not enough colour, too much background, and people couldn't actually see when things went wrong. And we keep the details that are there, but we only have them for the specialists, the application specialists, because they're the only ones that care. They're the ones that really need it. Service desk integration. I've done this twice. The two ways that I've done it, that I know work, I'm sure there's other ways. Pretty much every service desk has got an API, and you can talk to it direct. At a Nagios, that would involve using either notification scripts or event handlers and a lot of Perl code. Or the other way you can do it is you can use event management, which is the way I've actually done it this time around. The first time I did it was with a previous monitoring system and a product called InfraHelp, which had an API. And what we ended up doing was having to put a lot of code in order to turn events or status changes into help desk tickets. So what you end up with is coming out of your monitoring system, an enormous amount of translation in Perl or Python or Shell or whatever, but a lot of code. In our case, it was something like 20,000 lines of code to integrate into the service desk. What we got was very tight integration. And there was a lot of two-way comms between the monitoring system and the service desk, but it was a nightmare to maintain. It was a huge amount of work. It wasn't very elegant, but it did work very well. What we really discovered though is at the end of the day, people really didn't care. What they wanted to know was when there's a problem, get the ticket logged. If there's an additional problem on the same system, they want the ticket updated. So the way we actually did it with this time round with Remedy is instead of doing all the heavy-duty Perl work, so instead of 20,000 lines of Perl, this time round we've got about 30 lines, not 1,000. And all we do is we have a notification script, and in our templates for our hosts and services, we have a custom variable or a custom macro set. And in that macro, you put flags. And it's free-form text, providing the 3 letters SMS appears in there somewhere, in any format. What will happen is that when the notification script receives that variable, it'll parse that string, and if it sees SMS in there, it'll send out an SMS. It'll call a subroutine within the code to send out the SMS. We do the same thing with email. Same thing, and we can put these in any format, in any way. They don't have to be in any particular rigid format. The guys can put them, email, SMS, SMS, email. They can put them in camel case, uppercase, lowercase, capital case. I don't care, so long as the characters are there. Then came along integration to Remedy. So what we did was we thought about using event handlers and a lot of other stuff, and then we thought, well, the easy way would just be to add another flag and add another subroutine. So that's exactly what we did. We just added a flag of, so in that variable, you can have Remedy, SMS, email. And if you do that, if you put in all 3, you'll get all 3 kinds of notifications. If you put in one or multiples of any of them, then you'll get those kinds of notifications. They're all treated separately by the same common Perl script. Oh, and there it is there. So they're the flags, literally, email, SMS, Remedy. We put a custom macro. It goes in the top level template in our host and our service template at the very top level. And we also, well, I set it by default to email, so that what will happen is that if a contact or a contact group is defined for a service or a host, then they will automatically get an email. And then at lower levels, down through the hierarchy, what we'll do is, for instance, the Unix servers at the top level Unix template, we'll we'll change it, change the contact at that point, so that by default, every problem that occurs on a Unix host or a Linux host will automatically notify the Unix support team. Same with the Windows. We do the same thing at the Windows level. We use a common script for host and service because I got tired of updating multiple scripts all the time. And there's a variable that actually, one of the variables that gets passed, or one of the macros that gets passed into your notification scripts is the service name. And if that's empty, then we default to being a host notification. And the reason for that is that we need to know, because depending on whether it's a host or a service notification, obviously there's different information that goes out. So emails and SMSs were actually easy to handle. We sent those out we've got a custom built, to the network, it actually looks like an SMTP server, but it's actually an SMS gateway. So some mail goes in and SMS comes out. One of the things we found over the years was skip the email chain if you can. We actually code our notification script to talk directly to our gateway. So the only thing that's got to be up is the network and our SMS gateway. Far too many times we had troubles when we were doing email to SMS conversions and found that something along the line was broken. In fact, funny story, I was doing a monitoring job for one of our email teams many years ago, and the old standard thing, how do you want to get notified? And the usual answer is, just send me an email. And I said, you guys want to think about that? When your email system's down, you want to get notified how? And a lot of people don't think about it. Some of the things I've actually discovered along the way is try and minimise the dependencies in monitoring. In large organisations, we tend to have standard ways of doing stuff, standard SMS gateways, standard email gateways, standard for everything. Catch is that when you go to use those standards corporate systems and those things are not running, they tend to be failing at the time we really need to be running. So we tend to avoid DNS for server names and DHCP and all sorts of stuff. We hard-code lots of stuff into host tables, like purely not for stuff we're monitoring, but for ourselves to make sure that we can get to individual components within our own system. So our service desk ticket creation is actually handled by forming an event within the notify script and sending it via BMC event management. BMC event management is part of Remedy anyway, so if you've got most service desks have got some form of event management. It's a simple case of the same script that does the notify for emails and SMSs. It's just a slightly different subroutine, pulls out different variables, formats the event in the way that's required for BMC, and just fires it off to BMC. And we just fire it and forget it. And that's the end of it. That's the end of our part. In the old days with the other method, what we were doing was sending stuff to the help desk and then getting a reply back and then updating the monitoring system, and there was a lot of interaction backwards and forwards. And at times when things were going wrong, it could be very fragile. This is actually quite robust. The way we've set it up so that we've got a common script is that we have, and for Remedy, when you're dealing with help desk, you need to usually tell your help desk or your service desk who's going to go fix the problem. So what we did is that we already had everything in contact. All of our contacts were in contact groups, and those contact groups were the support teams anyway, so we thought, why not? So we used the contact group directly as the resolver group. Except for then what happened is that we started going through a whole series of department changes, particularly over the last 2 years. And those department guys, where they've merged departments, they've started changing their department names. And the resolver groups in the help desk didn't stay synchronised. So then what happened is that now we've got tickets going nowhere and lots of unhappy people. So the way we fixed that was just added another custom variable similar to the notification script, the notification method that you want to use. We've got another one right alongside it, and it's actually set as the default resolver for the ticket. So wherever that ticket is supposed to go to, it'll be set within the service or the host. And again, we can actually set it at the very top level to a default catch-all group. And then as you go down through the hierarchy of templates, we then split it up so that the right tickets get sent to the right resolver groups. But we've always got a catch-all in the template so that things don't go missing. So what does that really give us? What it means in simple terms is that we can control notifications. We can set them at the top level, and everybody gets a ticket, everybody gets an email, and everybody gets an SMS for every problem. Not such a good idea. Well, by setting it at the top level means that we can set the basic defaults, which is, at this stage, we just set it to email, so that at least an email will go out for something. As we go down through and get down to right down to service and host level, we're able to override the template and put in our own values so that without having to fill in every method on every service and every host, we're able to actually set just the ones that are important and make sure that the right people get notified and by the right method. Not everybody wants a service ticket or a service desk ticket for every problem. That's something that we've come across over the years. These days I'm actually quite reluctant to set it up for a service ticket unless I'm specifically requested to. So we can send out emails in SMSs and service desk tickets in any combination, and we've got complete flexibility. So in summary, what we found is that from experience, we found that if you go through the APIs, you get much more control. You can control very, very fine levels of detail of the ticket and the ticket attributes, but it's a lot harder to do. As I said, in the first time we did this, it took me 18 months and about 20,000 lines of Perl code. The second time around I did it via event management, and sure, you don't get quite as much control. You basically form the event the way it's required, fire it and forget it, but then it's a lot easier to do. It took me 30 lines of Perl and in one afternoon. So there's a bit of a difference. So, and as I said, with the API stuff, although we had super tight integration, and in fact the help desk vendor was quite amazed at what we did. They helped us a lot actually with, we had to get them to change some bits of their API because we found some of it didn't work the way it was documented. So we actually got them to fix things and even add new features for us. And we had very, very tight control, and we could do all sorts of whiz-bang things like stop the escalation clocks via resolved events and all sorts of stuff. But when it came right down to it, no one really cared. The most important thing was getting the events, or getting the service desk tickets created consistently. Because prior to automatic service desk integration, what we had was, depending on who was logging the ticket and what shift it was and whether or not they were busy with other things, would determine the quality of the data that was in the ticket. And so we ended up with the same problem being logged 10 different ways. Whereas now you've got absolute consistency, which means our service desk statistics are actually usable now. So, doing the mainframe alerts. One of the questions I got asked was, why on earth would you want to do that? We've got a whole bunch of operations guys. Why do we need to monitor this thing? And how? How are you going to do it? It's actually easier than it sounds. The reasons were simple. Most of our distributed apps on all of our dashboards that you see are all back-ended by mainframe transactional systems. So you've got all your fancy whiz-bang internet banking systems and payment systems and FPOS and all sorts of other stuff going on. But we're monitoring all the distributed stuff, but they all feed back to a mainframe. When that mainframe hiccups, and they do occasionally, not very often, but when they do, all of our dashboards stay a lovely shade of green, even though the app is completely unworkable. So we got forced to go into the mainframe area. Vendor options in this area were outrageously expensive. We literally got quoted for a single event adapter hanging off a mainframe. We were quoted upwards of $1 million just to get a stream of events out of a mainframe. Then they decided, because we weren't going to use the full product, we're only going to use part of it, they thought, yeah, well, we'll give you a discount. We'll only charge you 100 grand per year. So we thought, yeah, don't think so. We did it using MQ series or MQSI or WebSphere Business Integrator or whatever IBM calls it this week. You guys using mainframes or MQSI? These same methods can be applied to any large legacy system. Basically any dinosaur that's got TCP and logs, you can use the same methods. Via MQ, all MQ gives us is a connection from Mainframe World into a Windows server. And on that Windows server, we get a stream of events come through in a simple delimited message. So it comes down an MQ channel. You could be just getting syslog straight out of a mainframe. There's any number of ways you could do it. But what we do is we get it in a delimited format, which we chose purely by discussing it with our sysprogs on the mainframe. So it's similar to syslog format. We just basically get date and time, where it's come from, and what the problem is. And then we pull it apart with a Perl script when it arrives on Windows. And then with that Perl script, we're then able to then reformat it into anything else to get it into any other system. Now, this was originally designed many years ago to go from our mainframe into a previous vendor solution, event management solution. All I had to do in order to rejig it to make it work with Nagios was change the output so that it reformatted into a different format and send it to Nagios instead. And you can do that. There's lots of ways you can do that. Yeah, whatever option you've got available, basically. It's completely flexible. It's up to you. And you don't have to be a rocket scientist to actually do this stuff. I'm not a coder, but I've written all this stuff in Perl without any problems. So the way it works very simply is it comes out of Big Blue into Perl for some conversion. And the Perl script involved in this case, there's about 30 lines again, about 30 lines of code. And then we spit it out. We actually take it in via NSCA, but there's no reason why you couldn't do it any other way that you've got available. In fact, it doesn't even have to go into Nagios. In our case, it does. It could go into anything. So now that we've got the mainframe events are now coming into Nagios, and we map them into our appropriate apps. So our dashboards now show the correct status, and we've got happy NOC managers. So pretty much, unfortunately, mainframes are still with us. I know the IT pundits have been predicting the death of the mainframe for many years. They haven't died. They've more or less morphed into giant web application servers. I know with us, we've updated one of our updates some time ago. We pulled out an OS 390 and put in a brand new shiny ZOS box. And rather than getting rid of the OS 390, what they did is they turned it into a giant WebSphere server. So, and you haven't got all the aggro of trying to look after 50 or 60 Unix boxes to look after it. So they're still used for processing critical applications. Many organisations are using them. And if not, they may have scaled down, but you've still got similar problems with legacy systems. So these same methods can be used for all of them. And without the status of these back-end systems, your monitoring system status can never show the true accuracy of your applications, in which case, as we found, your NOC staff very quickly will discount the value of your dashboards if they're not showing the true status. So that's pretty much it from me. Is there any questions?
All right, if there's no questions, if you guys could put your hands together for Simon Finch one more time. Thank you so much, Simon. Really appreciate it. Thank you.